Okay, folks, it's time for the most interesting, coolest, and as I said before, sexiest track at FINOS to get back out of. There's no giggling at the back, sir. This is very serious. Thank you, that's more like it. Excellent. So this is confidential computing to demonstrate compliance. And we've got 30 minutes, and I have given a bit of an intro to what we're talking about, because you kind of need to know what it is. But first, I wanted to talk about what the CISOs care about, because I've spoken to a number of CISOs over the years, despite the fact they have the word security in their title, it seems to me that none of them really care about security. They care about the board and the auditors, but they don't really care about security and technology. Now, that doesn't mean that some of them aren't good security people or technologists, but what they really care about is risk. Managing, mitigating, and understanding risk, and security and technology is a way to deal with that. And so, when we talk about compliance, which I think is fair to describe as sort of policy plus audit, there's a reason for it, and it's from risk mitigation, right? There's a reason that people care about compliance, and the reason regulators care about it, because it's about ensuring that the companies and organizations under their remit have sensible risk management. So let's talk about policy, and let's talk about policy specifically as it relates to a sensitive app with some sensitive data in it. Those of you who came to my last talk will recognize some of these slides, and I apologize, but I thought it was important just to go over how it looks. And the point really is that you're like to have a policy which says that nobody should be able to look inside that, right? Having a hacker or a bank sysadmin, or worse, even a cloud sysadmin or cloud IT, looking into your sensitive app is a bad thing. And in most cases, even the banker themselves, does anyone call themselves a banker anymore? Anyway, the sort of owners of that app probably shouldn't be able to do so. And what confidential computing does is to provide a hardware-based way of stopping them getting in. So we have what are called trusted execution environments, which are environments in which executions happens, which are hopefully trusted, hence TEE, and they isolate, they stop unauthorized, or pretty much anybody actually, users or entities looking inside there. So it's not just human entities, it's things like the kernel, the operating system, the hypervisor. None of these can look inside that sensitive app and data. And that's the sort of thing that we want. And that isolation takes two main parts. One is confidentiality, which means that no one can look in, but also integrity means no one can change what's in there as well, which is also an important thing. But there's also something called remote attestation, and without going into details on this, which I did a bit in the last talk, that allows you basically to have auditability of what's going on in there, what that app is, what that data is, and it's cryptographically backed down to the hardware layer again. And this means that when we're talking about compliance, we have something which we can point to, which is a technically created, cryptographically hardware-backed statement, if you will. It can be a certificate, for instance, about what we've been doing. And it also stops all of those bad folks from looking inside, or even good folks. But it allows you to have those sorts of controls. So what it does, what confidential computing allows you to do, is to change your risk profile and to make statements which you can back up through auditability about that risk profile and that policy. So it changes how you think about the security and the compliance capabilities of what you're running. And this is where this magical thing, well, it's not really magic, but it kind of feels that way sometimes, of remote attestation takes place. And this is basically, you have a remote attestation service which sits off the box that is running your application and is run by a trusted party. That might be your own bank, it might be an ISV, it could be somebody else. But basically that checks that capability and allows you to use that cryptographic measurement for whatever it may be, such as auditing, compliance, etc. So confidential computing changes your risk profile and allows you to provide cryptographic assurances about it. So what sort of policies can confidential computing demonstrate? Well, you have these things on the left are what it provides. So we don't care about that. That's kind of technical stuff. In the middle is the properties that it does it. But what sort of statements could you make? You could make statements about the version of an application or its data. You can make statements about whether it could have been tampered or not. You could make statements about what authorization policies are associated with it. You could make statements about the provenance of it. Where does it come from originally? You can make statements about the privacy controls in there and about access as well. So these are all things that are hugely useful. And what I want to do is spend a fair amount of the rest of the talk is describing some use cases which have been provided partly by Red Hat, Intel and Microsoft, but we've got some other bits and pieces in there as well, where people are using these capabilities to meet compliance or regulatory requirements. I also want to leave a fair amount of time at the end for questions. But if you have questions as we go through, please do ask them. So before I continue, are there any questions about the stuff that I've talked about already? Is there anything I explained insufficiently or missed out, or any questions at all? No? Okay, well, let's carry on then. So these are the use cases I want to talk about. These are, in most cases, ones where we can point at particular customers. One of the problems with use cases in the security field is that nobody wants to talk about them, because you don't generally want to expose to other people what security measures you're using are, and therefore it can be quite difficult to get people to go on the record about use cases. But we've got some here which people are happy to be on the record about. So let's go on. So the first one is the Royal Bank of Scotland. I'm just doubting myself, and I think it might be the Royal Bank of Canada. It's I do apologise, it's Canada. So I apologise, somebody who actually knows the use case. Do you want to go through the use case, or do you want to explain the use case? You might do. No, okay, fine. I do apologise. I'll change this in the slides that I update. So this is Canada, not Scotland. Very similar, quite northern, very friendly people. Yeah, I probably better stop there, actually. I had a grandfather who is a newfie, so I have some. I'll get away with that, I think. So what they wanted to do is to enable a collaborative use of data, sharing data with retail partners. So obviously the bank knows how much money you spent and where, right? But they don't know exactly what you've bought it on. The receipts that come through are not there. On the other hand, the retail outlets do have that information, but they can't necessarily tie it to individuals. And what the opportunity was to combine that data in ways that allow both the bank and the retail partners to make recommendations to the customers, but without being able to extrapolate from the data that's being combined, or to look at the data that they don't have access to, because the regulators, regulators world over are very keen that banks shouldn't have access to all of the retail data, and vice versa. The retail folks shouldn't either. And so what confidential computing allowed in this case was for a virtual clean room to be created, into which data could be put, and it could be proved that the information coming out wasn't going to leak information that shouldn't be exfiltrated. And you can do that by writing an application and proving that it will never expose data in ways it shouldn't, then measuring that application using a cryptographic hash, and when you run that application in a trusted execution environment using confidential computing, you use attestation, which includes that hash, to prove that the version and the type of application you're running is exactly the one that you maybe submitted to the regulator or to an auditor before or afterwards. It doesn't really matter, because you can prove that what's running could not do the things that you're not allowed to do. And what's more, every single time you run this application, you create a new attestation measurement, which allows you to have a new audit point. So you can prove as you go. You could even, in fact, do it during, for each instance multiple times if you wish. It's not usually useful, but there might be occasions where that would make sense. So this means that you have information about each one. And let's say you discover that there's an error or a vulnerability in your code. You create a new version, you measure that, and then that goes in the record as well. So if your regulator comes to you and say, I know you found an error, prove to me that after that error was found, no instances ran which were using the old version, you can do that as well, because all of that data is in that measurement and cryptographically bound to that measurement. So that's a virtual clean room, and obviously there's lots of ways to collaborate in this sort of way. Please, a question.
Does the Royal Bank of Canada have to inherently trust the retailers? Do they have to have mutual?
No, they don't need to trust each other. This is one of the nice things. So these can be mutually distrusting parties. As long as they both trust that the application that has been written is doing the right thing, and they also trust whoever's checking that attestation, which they can check themselves if they wish, they do not need to be mutually trusting. So it's great that you can build applications for mutually distrusting parties. Interesting use case I've come across, people working on a hardware supply chain for cars, where they had multiple suppliers, and they wanted to know, for instance, that they had enough ball bearings from one supplier and enough head gaskets from another supplier to be able to make 1,500 engines. But neither supplier wanted to tell the engine manufacturer exactly how many they had, nor did they want that information to go to the other supplier, because that's commercially sensitive. So they were able to have an application which was able to process that data and give a yes or a no, frankly. And then, again, without leaking the data to any party. Okay? Right, let's move to another one, if that's okay. Please tell me that everyone knows what KYC in this room is. I know your customer. I'd be kind of surprised if you don't. I still can't see it without reading KFC, but then again, this is not my word. This is the Nationwide Building Society in the UK. Please tell me I think I've got this one right. And this is one of those ones where, in order to know their customer, they need to get information from other parties who are unconnected with them, maybe competitors of theirs, in fact. And they need to be able to check the date of birth or where someone was born or their credit history or whatever it may be. Again, without being able to look at the raw data itself. And again, these are mutually distrusting parties. They may be competitors, or they may be in the same banking group but have clear regulatory separation between them. There may be reasons that they can't share the data for cross-border reasons, for instance. And so not only does this data need to be combined, but there's also a requirement that it is always encrypted. And so usually what you do is you'd have to decrypt it somewhere, combine it, then encrypt the results and send it out. But there are times when that data is unencrypted on a machine somewhere that somebody has access to. And who do you trust to have access to it? Is it nationwide? Is it a third party? Is it one of these parties? And the answer is, well, there are times when it can't be any of those people. And what confidential computing allows you to do is to say, well, actually, it's always encrypted. Because, again, I've not gone to the details of the technology here, but what T's do is basically keep things encrypted, keep the RAM encrypted at all times except when it's on the chip. The exact implementation varies across different platforms, but that's the basic idea. So this allowed them to, again, prove not only to themselves and to their third parties, but to their customers and to the regulators that at no point could they be doing things they shouldn't be doing. There's some really interesting uses for ad tech as well, which isn't really a FINOS thing, but I've seen some very interesting use cases there too. It's kind of an obvious one, really. This is Microsoft, who decided 2 or 3 years ago now, I think, that they really ought to protect their credit card processing, given it's 25 billion or whatever it is, quite a large number. And so they made the decision to do all of their credit card processing in Azure, on their own hardware, using confidential computing. And it turns out that if you do this, there's a whole bunch of PCI DSS requirements that you just get tick boxes against pretty much automatically, because you can prove that all the measures to protect this data and its integrity, that's really important here, not just its confidentiality, are in place. So credit card processing, it's something that everybody does. It doesn't stop it being really important. And you can protect not just the transactional data, but also the PII that may be associated with it. GDPR is infamously, notoriously fuzzy about some of the protections that it expects. Phrases like, I'm not sure it actually uses state of the art, but things like encrypted where possible, I believe, are peppered through it in generally unhelpful ways. And one way to approach this is to say, well, rather than going to take measures which will just about meet probably most of the use cases, if you use confidential computing or a similar privacy enhancing technology by default, you can just prove, again, that most of these use cases get ticks against them. Most of these requirements get ticks against them. You can prove that you are meeting those principles relating to processing of private data because you are keeping it confidential, you're making sure that only the right people have access to it. You can prove that you're meeting your responsibilities, again. And if there's a better way of doing data protection by design default, I'm not sure I know of it. And all the other bits and pieces. I could have put more quotes in here, but I was running out of space and I was already getting bored, frankly. If you're excited by the GDPR, I'm very pleased for you and somewhat sorry for you. But then again, I get excited by confidential computing, so each to their own. I think it's a fairly obvious use case, GDPR. Oh, here's a nice one. This is from Red Hat, and they are working with a leading cryptocurrency firm and at least one, if not more, I think now, banks in Asia-Pac region. And as anyone who knows anything about cryptocurrency is probably aware, the regulators aren't entirely happy with it all of the time. And the particular thing they were worried about from the regulatory side was the signing of transaction data. And what they had been doing was sign everything with HSMs. Now, HSMs are lovely and, provide very high levels of assurance, but they are also quite slow. They're also difficult to manage, and they need really good physical protection. Oh, and as a gentleman from Intel points out from the back, they're also extremely expensive. And what this company ended up doing was designing a system where, yes, they still kept the keys, the generation of the keys and the management of the root keys in the HSMs, but they shifted the actual transactional signing to confidential computing. So that meant that you get close to native performance, because confidential computing is generally very performant. Don't get me wrong, you can write pathologically bad use cases for it, but you can do that for any technology. But generally it's very quick, it's very close to standard performance. But you still get very strong protections, again, and protections that you can point to, because you can prove that what you're running is doing what it should do. You can prove that the keys are being protected in the ways you expect, but you're never exposing those keys in clear at any point if you design your system correctly, which is, of course, what you need. So basically, you're extending the trust boundary of the HSM out into your standard computing deployment, if you will, whether it's on the cloud or internally. And I think this one is mainly internally, but they're looking to move to the cloud as well, whilst not giving up the protections that you need to be doing that. So the last use case I want to talk about briefly was for AI. Now, I talked this through slightly in my last talk, which will be recorded, and the slides are already up, I think. But it turns out that if you really want to protect your AI, there's a whole bunch of different things. So I spoke to an extremely large investment bank a few months ago, who, I'm not sure if any of you are here, but I suspect is at this conference. And they were saying they would love to be able to use AI more, but they don't trust it in the cloud, but they can't afford to do it all on-prem because GPUs are very expensive. And if you're not using them all the time, they're even more expensive when you think about the money. And so they wanted to be able to protect the data sets that were originally being used, the original training model. That's all really important stuff. But they also want to be able to protect the inference engine that they get from that. And they also wanted to be able to protect the queries being asked of that engine and the answers coming out. So, for instance, if you are looking to make a large acquisition, 3 or 4 billion, I suppose that's kind of large, and you put in a whole bunch of market data and internal data into your data sets, into your training model, that is what comes out of that is hugely sensitive, right? As are the questions you're going to be asking of it, and are the answers you're going to get. So all of these pieces need to be protected. But also, you really, really want to be sure that if I, as a bank exec, ask a question of this inference engine, should I buy company X for $8.6 billion, that the answer it comes back with has been derived from the initial data sets that I gave it and the initial model that I put in, and not somebody else's. Because that's a great attack vector if you can leverage it. So being able to show that all the steps have been met is another great use for confidential computing. And as I spoke to slightly in the last talk, we've talked about two different types of very good use cases. One where you've got multiple steps, and another where you've got a number of mutually distrusting parties. And you can prove to those parties, but also to regulators, auditors, and your board, that the right things have happened in all the right places along the way, because you can chain these cryptographic attestations which form an audit trail, both in time but also in terms of the systems that you're using as well, and the stack. So if you think this might be interesting, and you're looking for ways to use confidential computing, what might your next steps be? Well, obviously, the first thing you're going to do is, consider what relevant regulations and policies are applicable to you. One I haven't given an example of is DORA. We're seeing a lot of use for DORA, not for fedoras, sorry, for space DORA at the moment. I mean, if you want to wear a fedora, that's fine, particularly if you're from Red Hat, but for use cases relevant to DORA. And I said, maybe it's multi-party collaboration, maybe it's insider threats, maybe it's just being able to put things actually out in the cloud that you couldn't before, but being able to prove that you're safeguarding it. Don't take my word for it. You need to make sure that the measures that confidential computing can provide to you meet not so much your policies as the risks mitigations required by your policies. I think that's a better way of putting it. No security technology is perfect. Can these meet the requirements and hopefully exceed the requirements alongside all the other things you do, the contractual things, the process things, etc. But typically we see confidential computing raising the bar, and means that the actual processing part ceases to be the weakest link in the chain. That is the big change here. This is where you can then think about risk in other places being more likely to be of concern than the actual processing. So if you are happy with that, yes, but don't forget, although the sexy piece for the techies may be the isolation piece, it's actually the reporting that is giving value, much of the value to what you're doing, and which you can point to your auditor and to your customers as well. There are cases where you can say, look, we can provide you with this really high quality use case. And then, of course, the easy bit, right? Just deploy it. That's once you've written it, deployment's easy, right? Ops. I've never, ever had to work in ops. I think I've managed to... You can tell. Good. Yes, I know. I have great respect for ops people. I do realize it's not as simple as that. So last but not least, I wanted to introduce you to the Confidential Computing Consortium. We are part of the Linux Foundation. Obviously, we're big on open source as well, or I wouldn't be here. And we allow companies to work together in, well, everyone who knows about things like FINOS knows that you can work together in ways that, even if your competitors allow you to talk about approaches, we are just about to kick off a regulator and standards SIG, where we're going to be identifying appropriate regulators and standards bodies to be approaching and working with them to try and make sure that confidential computing is appropriately in there. And if you're in this room, you or your company should probably be thinking about joining the Confidential Computing Consortium, if you're not already members. If you're interested in membership, there's a bit here. There's a little bit about compliance materials. And here are some links to 3 of those use cases that I am able to share with you. Sorry? I've got it right there, yes. I obviously had a brain freeze when I was actually writing the slides. I will edit these slides to say Canada and upload them in the next half hour or so. So you're very welcome to download them. Let me just see if there's any more slides. Questions? Question for the gentleman there.
So I saw multi-party collaboration on your list, and I feel like that is such a tremendous benefit that you get when you take on confidential computing. Do you make seconds on multi-party collaboration and how confidential computing enables it?
So the gentleman was asking about multi-party collaboration and how confidential computing enables it. Yes, the basic story is, let's say that I need to be doing something with you, and we don't necessarily entirely trust each other. But I write an application, and that application does something that we both agree needs to be done, without giving away our data. I show you that code, or we go to a trusted third party and they look at the code, and everyone agrees that that code is going to do what we need to be done and nothing else. I then run that, or you then run, or somebody runs that, and it really doesn't matter who, in a confidential computing environment, a trusted execution environment, and then we take that attestation data, that measurement, and we use that measurement to convince ourselves that what we think is in there is what is in there. And now we know that we can collaborate. I can put my data in there, you can put your data in there, and the results we get out, we can also tag with this attestation, which means that we can prove to ourselves, but also to other people, whether it's our customers, our boards, our auditors, our regulators, that what has happened is what everybody agreed should happen. And we could tie that to particular versions of software and particular platforms and understand exactly what has happened and when. So it allows you to collaborate with people you don't know, don't trust, and to build some really interesting models. There's lots of interesting stuff going on in the Confidential Computing Consortium around this, if you're interested. Some really interesting Web3 use cases, actually, at the moment, which I'm very happy to talk about at huge length if anyone's interested. Sir, yes? So the question is that this organization has people who want to be able to share AI models, presumably, to be run on-prem by customers, but they're not sure they entirely trust the customer to do that. And the answer is 100%. I've come across exactly the same thing with someone who does software for call centers. And a lot of these are one-off engagements, or they try it out, and if they like it, they buy it. But the problem is that once you've given it to them to try, they can take it. But yes, you can absolutely run this in a confidential computing environment, and you can decide not to release the model or the software into that environment until you have proof that it's going into the proven thing. So we've talked about use cases where we put something in, then prove it. You can do it the other way around. You can prove that it's safe to put in, then put it in, and then run it, and know that when it's turned off, it's gone. So absolutely, it's a great way to run stuff on-prem. In the same way that you may not trust Azure with your model for whether you should spend 2.3 billion buying someone, you may not trust your client, well, which is entirely fair. It's, you know, there's only so much you can do. I spoke in the keynote about contractual law being sort of forward-looking, but litigation being backward-looking. Once it's gone, frankly. And this is a way of allowing people to use things, but not allowing them to get it. I think we're out of time, I'm afraid. And then some, I'm afraid. I will be around, though. Please do find me. I'll stick around in the room for a bit. If you have any more questions, thank you very much indeed for your time. And yeah, See you. Thank you.